Hello, ladies and gentlemen. Today we're going to talk about chemical quantities. So, we're going to move from regular units that we're used to in everyday life to some chemistry units. Today we're going to talk about counting particles with the mole. Substances can be measured in different ways. We can count things: 5 apples, a dozen eggs. We can look at the mass of something: 2 pounds of bananas, 16 ounces of cereal. Or we can talk about its volume: gallons of milk, pints of cream. So there are 3 different ways that substances can be measured. The mole can be related to each of these types of measurements. The presently accepted definition of the mole is the amount of any substance that contains as many elementary entities as there are in 12 grams of pure carbon 12. The mole, often abbreviated MOL, as a unit in chemistry, serves as a bridge between the atomic and macroscopic world. So a mole is almost like a meter. You can go from kilometers to centimeters, but you have to use that meter step in the middle. The mole is our middle step. 1 mole is equal to 6.02 times 10 to the 23rd atoms or molecules. That is 602 with that many zeros behind it, 21, or 602 sextillion atoms or molecules. There's a video down here that I would like for you to watch called How Big is a Mole? Make sure you do. There could be some upcoming quiz questions on that. This equality can be used as a conversion factor to convert particles into moles or moles into particles, which is what we're going to do today. So, our example says, how many atoms are in 1.22 mole sample of sodium? So I'm going to start with my known. 1.22 moles of sodium, and sodium is Na. My unknown, it's asking how many atoms, question mark, atoms of sodium. So my plan, I'm going to go from moles to atoms. Okay. First, I'm going to start with our mole, 1.22 moles sodium. I'm going to put that over 1, just like I normally would whenever I'm converting. I know that on the bottom, I need moles of sodium because moles of sodium is on top. They need to cancel out, so I have 1 mole of sodium. And the number we're going to use is that gigantic number 6.02 times 10 to the 23rd atoms of sodium. After I multiply that out, I should get 7.34 times 10 to the 23rd atoms of sodium. All right. Our next example, we have how many molecules are in 3.12 mole sample of potassium chloride. Notice that now instead of just one single thing, like we had helium or sodium, we're using a molecule. So there's different words. Our first one we use the word atom, our second one we're using the word molecule. It makes no difference in what we're doing. So our known is the number we're given, 3.12 moles of KCl. Our unknown, question mark molecules of KCl. So we're going to go from moles to molecules. Using Avogadro's number again. So I'm going to start with my known over 1. My mole is on top over here, so I know my mole needs to be in the denominator. On top, I'm going to put Avogadro's number, 6.02 times 10 to the 23rd, and that is molecules of KCl. I'm going to go ahead and multiply that out. My answer is going to be 1.88 times 10 to the 24th molecules of KCl. Right? We're going to do 2 more examples. Our next one says, how many moles are equal to 4.79 times 10 to the 24th molecules of carbon monoxide? So my known, 4.79 molecules of CO. My unknown, how many moles of CO? So I'm going to go from molecules to moles. Start with my known. Put it over 1. Make sure you use your units. Molecules CO. Now, molecules of CO is on top, so I know down here it's going to have to be molecules of CO. When I use Avogadro's number, it goes with the molecules. So it's 6.02 molecules of CO. And on top, 6.02 times 10 to the 23rd. Sorry. On top, we have 1 mole of CO. Go ahead and do that math. Notice now I'm dividing 4.79 times 10 to the 24th divided by I got 7.96 moles of CO. Right? In our last example, we are still going from atoms to moles. So my known, 5.86 9.7 times 10 to the 25th atoms of Pb. My unknown, how many moles of Pb that is. So I'm going to go from atoms to moles. Start with my known and put it over 1. I know I'm going to have atoms on the denominator because first my atoms are on the numerator. So this is our Avogadro's number, 6.02 times 10 to the 23rd atoms of Pb is equal to 1 mole of lead. And then we're going to divide that. And our answer, hopefully you guys got the same thing I did, 97.51 moles of lead. So you're always going to use this conversion factor. Just depends on what is up here. If atoms is up here, our large number goes on bottom. If moles is up here, our large number is going to go on top. Good luck with your homework. Let me know if you have any questions. Have a good day.